Greetings everyone. A very good morning. My name is Bazaru Venkata Sainithin. I am from Gokaraju Rangaraju Institute of Engineering and Technology, which is located in Hyderabad city of India. First of all, I am thankful to Tribhuvan University for organizing the 6th International Conference on Inventive Computation Technologies, ICICT 2023. I am thankful to the organizing team for accepting our paper at your esteemed conference. My co-authors are Kandada Sainithin, Banod Sneha, and this paper is completed under the guidance of Vadlari Vijay Kumar sir. The title of our paper is Non-Destructive Approach for Detection of Food Freshness Using IOT. Here is the abstract of our paper. The main focus of our paper was to develop a solution to detecting the freshness of food, that is fruits, vegetables, dairy products and meat products which are placed for a long period of time or stored for a long period of time. We aimed at developing an affordable, non-intrusive, automated and cost-effective approach to evaluating food quality. This innovative solution of ours can accurately assess the quality of food products without damaging them, allowing for a more efficient evaluation process. Before I go in detail about the presentation, I would like to give you a small scenario. Imagine there is a man who has bought fruits and vegetables for his home. Along with that, he has also bought milk products and meat products. He has placed these products in a refrigerator. Since the man was preoccupied with his work and everyday activities, he forgot about the products that he has placed in the refrigerator. After a few days, when he opens the refrigerator, he finds out that his fruits are spoiled, the meat products are spoiled, the vegetables are rotten. Now, in this situation, the man has wasted the money on spending these products. Not just wasting the money, he has also wasted the efforts of lots and lots of farmers in the world. Farmers put in a lot of effort working in harsh conditions to produce vegetables and fruits for us. But there are lots of people who waste these fruits and vegetables. They place them in the refrigerators and forget about them and throw them in the garbage the next day. Millions and millions of people in the world are not caring about the fruits or the vegetables that they are bringing home. Tons of food is getting wasted every day, leaving many people in the world hungry. The main problem here is not noticing the food getting spoiled or food getting rotten. This is a serious situation which is needed to be considered. The traditional methods of evaluating food freshness, such as smelling of food, tasting the food, or observing its color, are all outdated or time consuming or inefficient. They are prone to errors of human beings and they are prone to the environmental factors. As a result, it is important for us to develop a system which can detect the food spoilage without any human intervention and alert the human about it getting spoiled. There are various technologies which can be used for this purpose. There are various parameters such as pH, humidity, and oxygen levels which influence the spoilage of food. Understanding these parameters is essential to maintain the quality of food and prevent spoilage. Changes in these parameters can signal the potential spoilage of the food. Now that we have identified what the actual problem is, we are going to find solution to it. Technologies such as Internet of Things and OpenCV can be used to find the solution to the problem. The proposed project aims to develop a non-destructive and automatic system for detecting the freshness of various food products using sensors and OpenCV. The successful implementation of this project will have significant implications for food industry, leading to improved food safety and reduced economic losses due to spoilage. Additionally, it will promote healthier eating habits by encouraging the consumption of fresh and high quality food. Here is the methodology of our project. We have divided the project into two subsystems, a computer vision system and a food storage unit monitoring system. The food storage unit monitoring system can also be called as an IOT system. Various sensors are utilized in this food storage unit monitoring system, and these sensors are utilized to measure different food parameters, including gas level, pH, moisture, and others. As I've mentioned, these parameters are really important to understand the spoilage of food. Raspberry Pi mounted with PiCam is used for getting a continuous feed from the storage unit. Raspberry Pi is going to be the central unit of the project as it is used for analyzing and processing the information. Now let us look at the food storage unit subsystem. It consists of the sensors, pH sensors, gas sensors, humidity and moisture sensors, and more. These sensors monitor real-time parameters such as temperature, moisture, and natural gas emissions from food items. For example, pH sensors measure the pH of dairy products, while gas sensors detect the amount of natural gas emitted by a particular food. This method of evaluating food quality is useful in situations where food is tightly packed in a container or when food degradation occurs due to lack of fresh air, that is oxygen, or due to the growth and activities of microorganisms. The real-time data from these sensors is transmitted to a mini computer, that is Raspberry Pi, or a single board computer. This subsystem can monitor fruits, vegetables, meat, grains, and dairy products such as milk and curd as well. Now let us look at the computer vision subsystem. The OpenCV uses image processing techniques to differentiate between fresh and rotten fruits. The process involves capturing an image of the fruit and processing it through various stages of image analysis. These stages include pre-processing, feature extraction, and classification. Relevant features like color, texture, shape, and size are extracted from the pre-processed image. Machine learning algorithms such as decision trees, support vector machines, or neural networks are used to classify the fruit as fresh or rotten based on the extracted feature. Let us look at the various sensors that we have used in our project. pH sensor is used to measure the pH content of the milk products. The operating voltage is 9 volts DC, current rating is 1 ampere and has an accuracy of plus or minus 0.1 pH. The temperature range is 0 to 60 degrees Celsius. Moisture sensor. We are using moisture sensor in our project in order to find whether the grains are having water content in them or not. When the grains are having water content, it means that grains are getting spoiled. So using a moisture sensor means that we can constantly monitor the water content in the grains and alert the user whenever the moisture is high. DS18B20 sensor. This is actually a temperature sensor. It is a very versatile temperature sensor as it can be used for different kind of liquids. It has a temperature range from minus 55 degrees to plus 125 degrees Celsius. It can be used for hot liquids and also for cold liquids. The operating voltage is from 3 volts to 5 volts. MQ4 sensor. MQ4 sensor is used to find the ethylene content that is being released by the fruits and vegetables. When the ethylene content is high, it means that the fruits and vegetables are getting rotten. When it is low, it means the fruits and vegetables are fresh. The MQ4 sensor is having fast response and having stable and long life with a simple drive circuit. The Raspberry Pi. The Raspberry Pi is the main brain cell of our project. It is a small credit card sized computer, a single board computer. It is capable of running full-fledged operating systems like Linux and can be used for a variety of tasks, and it can be used to do lot of projects. Raspberry Pi is affordable and it runs on Linux. It can perform web browsing, word processing and programming. Raspberry Pi camera. The Raspberry Pi camera is part of the computer vision subsystem. This camera provides the Raspberry Pi with live feed or real-time images. It is small and inexpensive camera module that is designed to be used with Raspberry Pi. It connects directly to Raspberry Pi's camera port and provides high quality video and still images. ADC MCP3208. It is an analog to digital converter. Its analog inputs are programmable as single-ended or pseudo-differential pairs. It is a low-power CMOS technology and has a range of temperature from minus 40 degrees to 85 degrees. This is the architecture of our project. As I've mentioned before, it consists of two subsystems, a storage unit monitoring subsystem and a computer vision subsystem. This storage unit monitoring system consists of various sensors like the MQ4 sensor, pH sensor, soil moisture sensor, and a temperature sensor. These are connected to the Raspberry Pi and provide the Raspberry Pi with the data. Whereas the computer vision subsystem, which consists of the Pi camera, is connected to the Raspberry Pi to provide the real-time data of the images of fruits. Now, the information that Raspberry Pi is getting from these two subsystems, it uses them, it analyzes them and processes them and sends to the cloud. The data is stored in the cloud, which is then later accessed by a user from a remote location. In this way, a user present in a faraway location can actually monitor his fruits and vegetables placed in a storage unit. Therefore, he will be given alerts when the food is about to get spoiled. Now here is the result analysis section. This section will present the results and findings obtained from the experiments conducted. 75 tests were performed using various types of apples, bananas and oranges. An accuracy of 96% is calculated from the matrix, that is the confusion matrix. Now let me talk to you about the advantages of our system. Real-time monitoring. An IoT based system that we are developing can continuously monitor the parameters such as temperature, humidity and gas levels in real time. This allows for quick detection of changes that can lead to food spoilage. Non-destructive and automated. Our system is non-destructive, that is, it does not damage the food. The system can detect spoilage without the need for manual intervention, making it a non-destructive process. This is high efficiency and reduced labor intensity. Increased accuracy. The 96% accuracy that we have achieved is because of the computer vision system. OpenCV can provide accurate and reliable results in detecting food freshness compared to manual methods that are prone to human errors. Accuracy of 96% was achieved using the model, which is greater than the literature survey that we have conducted. Cost effective. IoT sensors can be cost effective compared to traditional laboratory equipment used for food testing. Early detection of spoilage. With continuous monitoring, the system can detect spoilage at an early stage, preventing foodborne illnesses and reducing food wastage. Scalability. This system can be easily scaled to accommodate different types of food products and production lines. Here is the image of the proposed model. Here are the results. One of the results of the pH values or the pH trend of a milk. As you can see, this is a graph plotting of pH values of fresh milk over time. It shows that there is a gradual decline in pH as the milk becomes increasingly sour. As the milk spoils, it undergoes chemical change that results in increased acidity and a decrease in pH value, which can be observed here. The bacterium lactobacillus found in milk breaks down lactose sugar into lactic acid. Therefore, the acidic content of the milk increases as it gets spoiled. So, the milk probe which is placed in the milk constantly measures the acidity of the milk, and it will alert the user whenever the acidity level reaches its maximum, and it can be called as a spoiled milk. The rate of pH decrease would accelerate as the milk spoils further, eventually falling below 4.6, the pH level at which milk no longer is safe for consumption. Conclusion. This paper suggests a non-destructive approach for identifying bruises in food products by utilizing computer vision, thereby ensuring quality and safety. Additionally, it proposes an IoT-based system that monitors and maintains food storage rooms to preserve the quality of food items for an extended period of time. The combination of sensors, IoT, and machine learning can revolutionize the food industry, reduce manual inspection tasks, and minimize human errors. This will create an environment where food manufacturers are encouraged to sell healthier food products and increase awareness of healthy food options among consumers. As a result, the food processing industry, which manufactures various food products, will have to prioritize food quality detection and management. This is the end of my presentation. I am thankful to ICICT team for organizing this conference and accepting our paper. Thank you so much.